2010.
Hold on. Okay, so one thing, because of the changes this year, there are certain things they're not testing you on, and because you can always use your calculator and you can use notes, my strategy for helping you solve a problem like this is a little different than what I had taught you previously. I think it will work better to take a slightly different approach. So what I mean by that is I have this little note box that I created and going to start using it whenever they talk about an absolute min or max. This box here that just appeared on the screen, do you see that?
Yeah.
Okay. So I want to use that whenever I encounter a problem that is talking about finding the max or min of anything. I want to follow these steps. Just make sure you don't mix it up with relative min or max. So are you okay that this is not asking for relative min or max?
Yeah, 'cause it wants when the line is longest to do the whole thing.
Perfect. And so the other thing that I didn't do when I made the video the first time that I think I would do now is, to me it's easier to understand the problem if we again keep track of what's the amount and what's the rate. So in this case, there's no symbol in the problem, but if I invent one, it really does help. So I'm going to write n of t. This pen is causing me trouble still, so hold on. So I'm going to write n of t. Can you see that in green on the side?
No.
Okay, can you see the side panel of all the blue big section?
Yeah.
Okay, so let me try a different color. Hold on. Let's try. Can you see the white?
Oh yeah.
Awesome. So I'd write on my paper, n of t is number of people in line. Okay with that? And I make note that that's an amount. Whoa, that's not what I wanted. So the number of people in line is an amount. You good there? Hello?
Yeah.
Okay. That means there is a rate at which n changes. That's n prime. And in this case, n prime is actually made up of two rates. There's the rate at which people get into the line. That's r of t.
And the 800.
And then you would subtract the 800 because that's the rate at which they're leaving the line. On the golden notes, there's a little box that says the overall rate is often the in rate, subtract the out rate. Let me get that in front of me so I can make sure I'm referencing that. So on the front page of the golden notes, if you look, just a little note I had. Hold on. Apparently not my best note because I'm not even finding it myself. Maybe I took it off.
It's on the front page.
Oh, I got it now.
I found it.
Just making a copy here. Hold on. One moment. Okay, so this box, do you see the new box that just appeared on the board?
Yes.
Yeah, that one comes in. So this happens fairly regularly on a question where they don't give you something for the amount, so you just invent it like I did. And then you have a rate, and that rate will be the in rate they give you minus the out rate they give you, like I showed here. Any questions about that? That feels okay so far, Amanda?
Yeah.
Kenzie, you all right?
I just,
yeah.
Go ahead, Amanda.
Huh?
Go ahead, Amanda, sorry.
what's confusing me is when I look at the graph, I know it doesn't have like the minus 800, but still I feel like the line would be longest when the most people are in line. So I feel like the most people are going in line.
Gotcha. See if
So
this.
I thought it was at times 2.
Yeah, same.
Gotcha. See if this helps. Okay, I want to show this two different ways. The first way I'm hoping will make sense, but it's a hard way to explain on a test. But let's start with that. So what's happening is, right at time 0, this pen is causing me grief, sorry. Right at time 0, hold on, come on board. Okay, so at time 0, which is right here, right? 1,000 people per hour are entering the line. That doesn't mean that you see 1,000 people. It means that there's a flow, and that if you sat there and watched for an hour, you would see 1,000 people walk into the line. Simultaneously, 800, and honestly, if you convert every single problem to like a tank of water, it's easier to talk about, because the line is no different than the tank of water. Does that make sense?
So it doesn't just like spontaneously appear, basically.
Correct. It's a trickle. And it's a trickle such that, yeah, if you stood there for 1 full hour, you'd see 1,000 people walk by. What's a little tricky is that that rate is always changing. So you don't really see 1,000 people walk by, and it's hard to say how many you would see walk by. But that's what the rate is predicting. So I picture a tank of water. There's a hose at the top, and you can see the water flowing in. You don't see 1,000 gallons per hour flowing. You just see some amount flowing, and you know if you stood there and waited for an entire hour, yes, 1,000 gallons would flow in. But simultaneously at the bottom of the tank, there's an opening, and water is flowing out at 800 gallons per hour. Are you both okay there?
Yeah.
Okay. So, Amanda, you tell me, at that moment, time 0, would you expect the water level to be rising or falling?
Rising, because you still have like 200 gallons like above 800.
The net, yes.
Like more is going in than is going out.
Correct. If you were to shut off the valve at the bottom of the tank and reduce the flow at the top to only 200 gallons per hour, the water level would rise at exactly the same rate as it was before I did that.
Okay.
Wait, basically the rate is increasing until time 3, but then it's decreasing after time 3.
Let me say it back to you. Depends on which rate you're referring to. So which rate would you be, well, no, see, that's where you have to be a little careful, Kenzie. Increasing, let me draw something here. This is a really good discussion, so let's don't stop talking about it. Hold on. Just gotta grab the pen. It all depends on whether we are talking about rate or amount, and whether we're talking about the rate increasing or the amount increasing. So at time 0, because the in rate is 1,000 and the out rate is 800, yes, the number of people in line is going to be going up at a rate of 200 people per hour. That's what n prime of, copy of this. So like, this discussion might take a while, but be patient, because once you understand this, you shouldn't, it really makes a huge difference. So hold on. So like what I just said was n prime of times 0 is 200. Meaning 200 people per hour are getting into line at time 0. So the line level is definitely rising at a rate of 200 people per hour. Go ahead, Kenzie.
Okay. I think what's kind of confusing about this problem is, like, we understand when something's a min or a max, but like the word problem format of it is just kind of confusing.
Absolutely. The way to get past that is to go back to this box here. See where I'm pointing? And again, pay attention to every problem just really can be, well, a lot of these problems can be kind of patterned the same way. You have something, some amount of something, and then you have a rate at which that amount will go up and go down. And in this case, that rate is just two rates combined, an in rate and an out rate. And so, really, if I can always go back to this pattern, then I can solve all of the problems they give me of this style in the same way. It's probably going to work better if I ask you questions and not talk quite so much, because then I can really see what's making sense to you and what isn't. So, from time 0 to time 2, this graph goes up. So that indicates what, either of you? Like, what is that indicating?
The rate people are getting in line is going up.
Perfect. So you could say that. You could say that's little r. So we could say for, now keep in mind, we're not really trying to answer the question, we're just trying to understand. So for time 0 until time 2, r of t is increasing, because you can see the graph of r of t increasing. Right here, r of t is going up.
Would like big R of t also be increasing? Because if you subtracted 800 from any of those numbers, it would still be going up.
Right, so the symbol I'm going to use for that is what I had on this page, where I said my n is the number of people in line, and n prime is the rate at which that number changes. So absolutely correct that for this time period, n prime of t is also increasing. Because all you're doing is saying, oh, at time 0, n prime is 200. Answer this one for me, Amanda. What would n prime of 1 be approximately, as best you can tell from the graph?
300?
Perfect. Does that make sense?
Uh-huh.
And then, Kenzie, tell me, what would n prime of 2 be, as best you can tell?
400.
Make sense?
So you can tell it's increasing.
Just don't use the word it. What's increasing?
N prime.
N prime is increasing, yes. Because n prime, again, is nothing more, that's the board again, hold on. So n prime again, is nothing more than whatever you see on the graph, subtract 800. So it's whatever you see on the graph of R, subtract 800. That's what n prime is. So when we see little r going up right here, that means n prime has to be going up as well. Now the follow-up question is, what's happening to the number of people in line? That's a Danica's chart idea, because we can say, here's n, and here's n prime, and whenever n prime is positive, that tells me n is increasing. So from time 0 to time 2, I see n prime increasing, but I also know that because during that time n prime is positive, n will also be, n itself is increasing during that time. Are you with me so far, both of you?
Yep.
Okay. Amanda, do your best, and mistakes don't matter. It's just all about talking about it till it makes sense. Welcome, Julia. Can you hear me? Julia, can you hear me? So turn your mic on for just a moment, Julia, and just say you can hear me, and then you can turn your mic back off if you want. It's up to you.
Yeah, I'm good.
Okay. We're just kind of in the middle of this discussion, so just listen in, then we'll kind of go from there. What I'm trying to do here is not solve problem 2010 3C. I'm trying to help Amanda and Kenzie are the ones that were listening so far, just trying to help them understand the overall concept so that with future problems, you'll be much better equipped to answer anything that is asking about absolute min or max. So try and answer this if you can, Amanda. We know that from time 0 to time 2, the rate at which people get into line is increasing. And then because we knew that n represents the number of people in line, and n prime represents the rate at which that number changes, n prime is just my in rate, subtract my out rate. So here's my n prime. We know that n itself will increase from time 0 to time 2. When does n prime, so n prime is 200, 300, 400. What's n prime of 3, Amanda?
Well, it would be 0 because it's 800 minus, because 800 minus 800 is 0.
Perfect. Because the in rate is 800, the out rate is also 800. That
So
does.
the rate of 0 people getting in line.
Perfect. What's really happening is you see people getting on in line, you also see people leaving the line. But because the rates are exactly the same, the line's length itself doesn't change.
Oh, so that's like n changing increase to decrease. But that change positive, n prime change positive to negative. Oh.
Does that make sense? You can see it better, right? Like, answer this one for me, Amanda. If I asked you to tell me, and it's going to have to be an estimate, but if I said, what's n prime of about 3.1? What are you going to say?
Like negative, like 10, like minus 10 or something?
Yeah, something like that. The idea being that just, any fraction of time after hour 3, that's when the in rate becomes
Smaller.
just barely smaller than 800, so my overall rate n prime becomes negative. And when n prime becomes negative, that's when the number in line starts to go down.
Okay. That makes so much more sense.
Awesome.
Okay.
No,
It's just confusing because they
go ahead.
give you the graph of like
Only the in rate.
and stuff, but it's only the in rate, not the out rate.
So this problem would have been a lot easier if they just gave you the graph of n prime, like with the minus 800 in it. Then you would see it change positive to negative.
Correct. No, but as we always talk about, they're always looking for a way to present the information that hides it from you. And so what I'm trying to do is get you to, as best you can, not think of the problems as being different, but always going back to something like this right here that I'm circling now and saying, no, that's, it's really just this again. There is some amount, there's some rate at which that amount changes. That overall rate is just an in rate minus an out rate. And if I can find that in the problem, then I can make problems that seem very, very different become the same.
Can I ask another question?
On this one,
It's on the same packet.
same packet. Hold 1 second, Kenzie. Let's make sure we get this wrapped up, and then I'll stop this recording and we'll switch to a new question. So you're next for sure. No worries. So Amanda, do you have any question about the fact that then I can see now that from hour 0 until hour 3, n prime is definitely going to be positive. Therefore, n will definitely be increasing during that time period. And I know I'm starting to sound redundant here, but I just want to make sure. And so then you know from hour 3 until hour 8, because the value of r on the graph is always going to be less than 800, it's going to cause n prime to be negative during that time period.
Yeah.
Good. Okay. Awesome. And so that's why the answer you now see on the board in brown was the correct way to determine at what time is the ride the longest. Now I did make a mistake here. I should not have included this part of the question. They have said that they are not going to be asking you to calculate the number of people, like in this example, they're not supposed to be testing that this year. That part there I just crossed out.
Okay.
So anyway, Kenzie's ready for the next one. Amanda, do you want to talk more about this, or are you ready to go on?
I'm just going.
Julie, did you have any question about this one, or are you just listening in at this point?
No, I'm just listening right now.
Awesome. You're totally welcome to keep listening. So, okay, I'm going to stop this. I'm going to stop the recording, just so other people can watch it later if they want.